At the end of Module 4, we discussed variables that took on only two possible values, 0 or 1. These variables were called dummy or indicator variables. There's no need to discuss them further here. This screencast is about using an interaction term as an independent variable in a multiple linear regression model. We present this new idea in the context of our previous example that used radio advertising expense and newspaper advertising expense to estimate sales. Before we add an interaction term, let's review our earlier attempts to use radio and newspaper to estimate sales. We first fit the simple linear regression model that used only newspaper advertising expense to predict sales. We obtained an adjusted R-squared value of 21%. 21% of the variability in sales was explained by newspaper advertising expense. The hypothesis test for model utility had a p-value of 1.7%. At the 5% significance level, this was a useful model. However, there was a significant amount of curvature observed in the residual plot versus the newspaper advertising expense, and this curvature made the use of this model undesirable. We next fit the simple linear regression model that used only radio advertising expense to predict sales. We obtained an improved adjusted R-squared of 46%, and the hypothesis test for model utility had a p-value of only 0.03%. However, there was significant curvature in the residual plot versus radio advertising expense, and this model was also considered undesirable. The most recent model fit was the multiple linear regression model that used both radio advertising expense and newspaper advertising expense to estimate sales. Once again, we saw an increase in the adjusted R-squared, this time to 79%. And the hypothesis test for overall model utility had an extremely small p-value. This tested as a useful model. The hypothesis test to determine whether radio advertising expense is a useful predictor in the multiple linear regression model that also contained newspaper advertising expense. That hypothesis test also had an extremely small p-value, indicating that radio advertising expense is a useful predictor in the multiple linear regression. The analogous hypothesis test to determine whether newspaper advertising expense was a useful predictor in the multiple linear regression model that also contained radio advertising expense. That hypothesis test had also a very small p-value, indicating that newspaper advertising expense was also a useful predictor in the multiple linear regression model. However, once again, the residual plot versus radio and the residual plot versus newspaper had significant curvature. Although all of the model's statistics improved in the two independent variable model, the curvature remained a concern in terms of using the model. Now let's obtain an interaction variable column. We do that by multiplying the amount of radio advertising expense by the amount of newspaper advertising expense in each city. We obtain a column of those products. Here are the Excel formulas that will do the job. The idea is maybe there is an interaction between this auditory variable and this visual variable that will help us do a better job in predicting sales. We now fit the three independent variable model using radio advertising expense, newspaper advertising expense, and the interaction between radio advertising expense and newspaper advertising expense to estimate sales. We've moved to the next page where the regression output for the three variable model that includes the interaction term appears. Let's look at some of the results on this output. The adjusted R squared has increased to 87.2%. The standard error, or residual standard deviation, has decreased to $123,572. The p-value associated with the hypothesis test for overall model utility has an extremely small value, indicating that at least one of the model coefficients is different from zero. Here are the estimated model coefficients: B0, B1, B2, and B3. Here are the p-values to test the usefulness of the individual independent or predictor variables in the multiple linear regression model. For the radio advertising expense variable, the p-value is extremely small, indicating that the coefficient of radio advertising expense in the true multiple linear regression model is different from zero, which in turn indicates that radio advertising expense is a useful predictor variable in the context of the multiple linear regression model. For the newspaper advertising expense variable, this p-value is also very small, indicating that the coefficient of newspaper advertising expense in the true multiple linear regression model is different from zero, indicating in turn that newspaper advertising expense is a useful predictor in the multiple linear regression model. Finally, for the interaction term, the p-value is less than 1%, again indicating that the coefficient of the interaction term in the true multiple linear regression model is different from zero, which indicates that the interaction term is a useful predictor variable in the context of the multiple linear regression model. For all hypothesis tests, you should understand and be able to create all 5 steps. At the bottom of this page, there are 2 U-try problems. You should work through these U-tries. Read through the discussion on this next page. On this next page, read through the 5 steps of the hypothesis test for the utility of the radio and newspaper interaction variable. On the next 2 pages, review the residual analysis for the model with interaction. We've moved to the next page. Note that even though all summary statistics have improved when the interaction term was added, there still remains some curvature in some of the residual plots that continue to place the use of this model at question. Using an interaction term in a regression model can make it more difficult to interpret the estimated regression equation. The use of calculus can help. In this expression, we've taken a derivative of sales that is a derivative of the estimated regression equation in respect to radio, and obtained this expression. Here we've taken a derivative of sales, that is of the estimated regression equation, in respect to newspaper, and obtained this expression. In this you try problem on the next page, you're asked to use the derivative expressions in a specific situation to determine the increase in sales for an additional dollar invested in each form of advertising. On the final page of this module, you are asked to complete 3 you try problems or questions that will set up one of the problems on homework 5. This will complete this screencast.